morning everyone and welcome to Data Science Open House 2020. First of all, this afternoon we will have the presentation of two speakers, Dr. Giacomo Nannicini, Research Staff Member at IBM Thomas Watson Research Center, and Francesco Tudisco, Assistant Professor at Gran Sasso Science Institute. Right after them, we'll proceed with the presentation of our four curricula made by our professor. In the last part of the presentation, for all our prospective students, we have prepared a presentation with tips and tricks, overall information, as well as admission requirement given by our professor and admission officer. So, thank you very much and enjoy your open day. And now let's start with the welcome speech of Professor Ferrante, Head of Data Science Master Degree. Thank you.
The University of Padua is one of the oldest universities worldwide, counting 800 years of history. Founded in 1222, it has been home to figures such as Andrea Vesaglio, Copernicus, Galileo Galilei, and William Harvey. And in 1678, it became the first university in the world to award a university degree to a woman, Elena Lucrezia Cornaro. Despite its age, Padua is still a very dynamic, highly ranked, and innovative university. It counts more than 2,500 professors and researchers, around 60,000 students, and more than 160 bachelor and master's degrees, which cover almost all the fields of human endeavors. In 2016, we have established a new master's degree in data science. This has been possible thanks to a faithful collaboration between the departments of mathematics, statistics, information engineering, general psychology, and biomedical sciences, and the Bruno Kessler Foundation in Trento. Such master's degree is highly interdisciplinary and is fully taught in English by internationally established researchers. The Data Science Master is structured according to several curricula. Starting from the basic tools of probability theory, statistics, and computer science, which are common to all the curricula, we provide the students with all the fundamentals, theories, and tools that are required by a data scientist today, including machine learning, operational research, artificial intelligence, network science, and big data computing. Besides, we offer a wide range of courses where the previous tools find a practical application, like biological data, human, cognitive, and social data, or economic and financial data. In the final semester, all the students have an opportunity to carry out an internship in a private company or in a research institution to work on their master thesis. The University of Padua has experienced many of the darkest moments in the human history, such as wars and epidemics, and has been always able to start over stronger than before, always faithful to its motto, Universis Patavina Libertas, Liberty of Padua, universally and for all. We are now all facing a new, very strong enemy, but we are prepared to overcome this difficult and new challenge and to handle all the possible scenarios that the COVID pandemic may offer. This is the University of Padua. This is the master degree in data science at the Department of Mathematics, and this could be the right place for you to start your future into the worlds of business, research, and academia. We are waiting for you.
Hi, my name is Giacomo, and I will give you an overview of some data science-related projects at IBM Research. And I'm going to start with just a little bit of background on myself, and then I will talk about some of the intersections between optimization and machine learning that I've been looking at in my research, and also some of the intersections of optimization with quantum algorithm, which is another huge part of my research. So just a few things about myself to set the context. I'm working as a research staff member at IBM TJ Watson, which is a research center located in New York State, and I'm working in the quantum algorithm group. Before moving to the quantum algorithms group, I was in the mathematical sciences and business analytics group. I actually did part of my studies in Italy at the University of Florence, where I have up to a master's degree in computer engineering, Ingegneria Informatica. And then I moved to École Polytechnique in France for a PhD in computer science. I then worked as a postdoctoral research fellow at Carnegie Mellon University and at MIT, and finally worked for a few years as an assistant professor at the Singapore University of Technology and Design, after which I moved to IBM TJ Watson. And now one may ask, what is the common theme about all these places where I've been and where I worked? And the answer is very simple. I've been working on optimization. Many flavors of optimization, but still always optimization. So for you, I'm assuming that the most interesting part to hear from me is what am I doing at IBM Research? And so I can give you a very brief overview, and it will be brief because IBM Research does many things. In general, IBM Research does a mix of applied and foundational research. So some groups tend to work more on applied research, some groups more on foundational. Generally, I've always been in groups that work on more foundational research, but groups collaborate together very often. So there are always many opportunities to work on different projects. And some of these projects come from other IBM divisions, other times they come from industrial partners or clients or even government entities. And when it comes to the research, some of the output produced is made available in the public domain. And by this, I mean that sometimes the output of the research is published in journals or any other suitable outlet for publication. And sometimes if you produce software, it is made open source. But of course, this is not always the case. So some of the research output may be kept confidential, especially if it's part of collaborations with other companies. Now, of course, this is a very general overview. It is very hard to characterize what happens in all of IBM research. I can only give you an overview of what I see and what I have done. And in my specific case, I spend most of my time working with colleagues to determine what problems are relevant to solve and then trying to solve them. And most of the time, what I do eventually gets published. Sometimes it also gets patented, but I would say in the vast majority of cases, we do produce publications that are then in the open domain. And of course, the crucial question here is what are relevant problems, and here there is interest in both foundational research questions that may lead to important discoveries or things which are of more direct industrial interest. On top of that, I also collaborate with industrial partners and clients, and I also write software. I will talk a little bit about some of the software that I write in just a few minutes. Now, I don't want to bore you too much with just talking about myself, so I will jump straight into some of the things that I have been working on while at IBM Research. And you'll see that all of these are related to optimization in one way or another. And I'll start with a couple of things that are at the intersection of optimization and machine learning. So for some time, I worked with several other colleagues on some ideas to translate symbolic regression into an optimization problem. So what is symbolic regression? In machine learning, one of the common tasks is to build a model that explains a data set. So you have some data that you would like to construct some form of model that is able to accurately predict different unseen data points that come from the same distribution. In symbolic regression, you do share this task, so you are trying to find a model that explains some data set, but you don't assume that the functional form of this model is known a priori. So generally, if you construct, for example, a neural network or some support vector machines, the output of training a model will be some model that belongs to the class of all support vector machines, all of which, for example, or neural networks, all of which have some pre-specified functional form. And in symbolic regression, you just want to find a mathematical expression, whatever that is. So the space of the outputs of learning a symbolic regression model is the space of all possible mathematical formulas. So in particular, to perform symbolic regression, we need to define a space of valid mathematical expressions and a mechanism to explore this space. Now, in this specific piece of work, we decided to represent mathematical expressions by means of expression trees. And you can see an example of expression trees on the slides. So what you can see here is that if I have an expression 2w1 plus w2 to the third power plus 1, I can represent it as a tree where I have some leaves that represent my variables, w1 and w2. And these two variables get added together because there's a plus between them, after which I take the power of this whole subtree expression, and the exponent of the power is 3, and so on and so forth. So this is a convenient graphical way of representing any mathematical expression. And so what we did is that we formulated an optimization problem that takes as input a data set. So the data set as usual consists of several tuples where you have some variable that you have to explain why, and a bunch of independent variables, x1, x2, up to xn. And the goal of this optimization problem is to construct the smallest formula of x1, x2, up to xn that produces y. And here, when I say smallest formula, I mean any valid mathematical expression. So in order to do so, what we do is that we translate all the valid expression trees as the search space of an optimization problem. And then we optimize over this search space. So in particular, the decision variables of the optimization problem that we define determine an expression tree. So the structure of the tree and what are the leaves of the tree, what is assigned to each one of the nodes. And to give you an example of what this type of approach is able to produce, here I'm reporting some results from using a data set taken from NASA that has several tuples. This is data actually recorded from NASA, and it contains information on planets and stars. In particular, we have, for each planet, we have the corresponding star, and then we have the orbital period of the planet, the mass of the star, the mass of the planet, and the major semi-axis of the orbit of the planet. This is real data. And then we use the approach that I just described to try to explain the the major semi-axis of the orbit d. So we try to find a formula where the dependent variable is d. So d is our y here that we want to find. And by running this approach, we're actually able to find simplified expressions of Kepler's third law. Now, Kepler's third law would be that d is equal to the third root of some constant times tau squared times capital M plus small m. And we're actually never able to pick up the dependency on the small m, because this is the mass of the planet, which is tiny compared to the mass of the star. So even when we require very small error in the formula, we find an expression that is accurate, except for this, for the dependency on the mass of the planet. And here, what you can see in this table are the formulas produced by this optimization approach on different data sets, all of which are taken by taking subsets of this NASA data set, and imposing different bounds on the maximum relative error that the formula can produce. So if we require only 2% relative error, we find, as I said, this quite accurate expression for Kepler's third law. And then as we increase the allowed relative error, we found formulas which start getting simpler and simpler. For example, if we allow very large maximum relative error, then this approach tells us that a formula that just looks at the square root of tau is actually a good answer. And of course, if you want to get smaller error, you need to increase the complexity of the formula that is allowed to be returned by the algorithm. So this is one of the examples that I wanted to show you. It's very much at the intersection of optimization and data science. It's not the only example that I have where we look at the intersection between optimization and machine learning. There's a second one, and this is related to what is generally called hyperparameter optimization. And the context for hyperparameter optimization is the following. It's the context of trying to automatically deploy a machine learning model. This is, of course, something that is very valuable because machine learning is used extensively in many fields of business, and therefore there's a lot of machine learning models that gets constantly produced. And finding ways to automate this process is, of course, something that can be a game changer and can save a lot of time. Now, one thing to note is that every machine learning model has a lot of what is generally called hyperparameters. So what are these hyperparameters? If you take a machine learning model, for example, a support vector machine or a neural network or random forests, you will see that before you actually train one of these models on a data set, you have to choose a number of parameters. For example, for support vector machines, you need to choose the type of kernel that is used in the support vector machine. You need to choose some regularization parameter, and so on and so forth. And if you're trying to train a neural network, then you need to decide the architecture of the network. You need to pick activation function for the layers of the network. You need to choose a learning rate, and so on and so forth. So for every machine learning model, there are several parameters, which we will call hyperparameters, that you need to choose before you actually start the learning phase. And then after you choose the hyperparameters, you can train your model and then look at how this performs. So if we want to look at the problem of choosing hyperparameters as an optimization problem, we can formulate it as follows. So suppose we're given some data set, and then for some given value of the hyperparameters of a machine learning model, whatever these hyperparameters are. For example, for the neural network, they will be something that determines the architecture, the activation functions, and so on and so forth. So as I was saying, once we're given a data set and a set of hyperparameters for a model, then we can define some function, which is what we call here Fm of the dataset and hyperparameters, as the performance of the machine learning model M on the dataset. And here you can think of your favorite measure of performance, something that estimates the generalization error of the model. And then what we do is that we try to optimize the value of these hyperparameters x1, x2, up to xn, that optimize this measure of performance. And notice here that I'm not telling you what is the form of this function f, because in fact we don't really know what is the form of this function, but we can certainly assume that this function exists, because once the dataset and the hyperparameters and the machine learning model are given, then I can compute the value of this function. So putting everything together in this optimization perspective, our goal is to search for the values of the hyperparameters that optimize the measure of performance of a machine learning model on a specific dataset. And there are several important things to note here. One is that we do not know the form of this function. As I just said, this function is something that we can evaluate, but we don't have a mathematical expression for it. What we know is that given D, given the type of machine learning model and given the hyperparameters, we have a procedure to compute the value of f. However, not only we don't have an expression for f, but it is in general a stochastic function. So what I mean is that the output of this it should be considered a random variable. If we train the same machine learning model with the same hyperparameters, on the same data set, we may obtain different values depending on a random seed. So there is stochasticity involved in evaluating this function that determines the performance of a model. And on top of this, even simply evaluating this function may take a very long time. If you think about training a neural network, this could take minutes, it could take hours, it could even take days. So whenever we try to optimize this function, clearly we should try to optimize it while evaluating it at a small number of points, because every time we want to evaluate this function at some point, it may take a lot of time. And another source of difficulty is the fact that these hyperparameters that we need to choose may be continuous values, so real numbers, but they may also be discrete values like integer numbers. If I'm deciding how many units I want to put in a layer of a neural network, that's an integer number. I cannot put 3.5 neurons. But they can also be categorical variables. So here, by categorical variables, I mean variables that take value in some finite set that doesn't have a concept of order. For example, if I choose the type of the kernel for a support vector machine, I can use a polynomial kernel of some degree. I can use a Gaussian kernel, and I cannot compare a polynomial kernel to a Gaussian kernel. I just know that they are different, but there is no notion of distance between the value polynomial or the value Gaussian for the kernel. And similarly, if I look at the activation function for neural network, I know that there are several values that are possible, but among these values, I cannot really compare them. I just know that they are different, and then I need to choose one of them. Whereas if we're talking about the example that I was given for the number of units in a layer of the neural network, so what I call discrete parameters, these values, they're numbers, so I can at least compare and know which one is larger. So all of these things, they add to the difficulty of the problem. And so part of my work at IBM involves working on algorithms and software to solve this hyperparameter optimization problem. And in particular, I work on a library that's called RBFOpt. And this uses techniques from an area of optimization that is called derivative-free optimization. The specific approach that is implemented in RBFOpt uses the idea of a surrogate model of the objective function. So what's a surrogate model? It's a model that we try to learn to match the shape of this objective function, this function fm here, that we don't know. So we evaluate the function at several points, and then we try to guess a model for this function, and then in an iterative fashion we try to improve the model, but at the same time we also try to find better points based on the knowledge that we acquired of this unknown function. So this is sort of the general scheme, but of course, as you might imagine, there are several tricks that are involved in trying to make this general scheme work. In particular, RBFOpt uses many tricks such as local search. It does automatic surrogate model selection by looking at the performance of several models for the unknown objective function. It uses many techniques to rescale the function value so that we don't run into numerical troubles or ill-conditioned systems and things like that. And just to give you some visual example of what applying advanced optimization techniques can do in terms of savings, I'm going to show you here the performance of just a few different optimization algorithms on a problem of this form. Here I'm using an artificial function that we're trying to minimize, and this function is given to some optimization algorithms as an oracle. Here by oracle I mean that these algorithms are only able to evaluate this function. They do not know the form, the mathematical expression for this function. They do not know the gradient of this function, but they're allowed to evaluate this function at any point. And because, as I mentioned earlier, in typical applications, each of these function evaluations can take a very, very long time, we put a limit on the number of function evaluations that each algorithm is allowed to do. So in particular here, most algorithms will work with only 50 function evaluations allowed. So we tell the algorithm, you are only allowed to evaluate this function at 50 different points. Try to find a minimum of this function. And in this example, the minimum is actually located here in this part of the domain. There's actually another minimum right here. So this first example is showing you the points that are evaluated by an evolutionary algorithm. So evolutionary algorithms and genetic algorithms are very often used for this type of problem, but they can be inefficient. You can see in this case, the algorithm with only 50 function evaluations does not actually find a point close to either of the global minima, which would be here or here. We can then increase the number of points that the algorithm is allowed to evaluate. This is the same algorithm, but now it is allowed to evaluate 100 points. It still doesn't really get too close to the optimum. Now, eventually, if we allow 1,000 points, then the algorithm does find something which is very, very close to the global optimum. And then you can see this funny distribution of points here, which is most likely due to the algorithm mutating the best candidate that it found. So this is an example of the performance of an evolutionary algorithm on this specific function. Here's another example. This is the optimization approach called controlled random search, which is a mix of random search and then local search based on the best points found. And you can see once again that with just 50 points allowed in terms of evaluation, this approach does not get very close to the global optimum. It gets something not too far here, but the true optimum would be closer to the center of this ellipsoid. And the last example is taken from the algorithm implemented in the library that I developed. And you can see that it does a much better job at finding a point very close to the global optimum with even just 50 points. And another interesting thing that you can see is that it distributes the function evaluation in several parts of the domain. And the reason it does that, it's because it is trying to learn the shape of this unknown function. And then, as you might imagine, after learning the shape of the function, then it has a much easier time to in trying to guess where the optimum of this function might be. And so to conclude this part, as part of what I do at IBM, I also develop software, but of course also the algorithms that are implemented in the software. And this is very much, once again, at the intersection of optimization and data science, in particular machine learning. And the last part of what I would like to talk about is about quantum algorithms. This is a huge part of my research in the last few years. And this is something that you may have heard about, you may not know much about. I think it is extremely interesting because quantum computers offer a different model of computation. And if you're not familiar, the idea of a quantum computer was proposed in the 80s by Feynman. And these were initially thought to be devices that could be used to simulate quantum mechanics, so to simulate nature. And then, as it turns out, they also have other applications. And since this visionary idea, there has been a lot of progress in actually constructing quantum computers, so much that now you can use real quantum computers on the cloud. So you can design your quantum programs and run them on the cloud and get results. And I should not hide the fact that even though there has been a lot of progress, still a lot more progress is needed if we want to perfect the technology. So the current hardware implementation of quantum computers are still very noisy, and they still have several difficulties that should be dealt with if you want to construct a computer that behaves like the theory predicts. So why are we even interested in this? Well, as I said, the main reason is the fact that quantum computers use a different model of computation from traditional computers. We are used to computers as machines that are based on a model that in theory is called the Turing machine. And we have at this point, intuitive understanding of what they do. Quantum computers use the laws of quantum mechanics to perform their operations. And for this reason, there are problems that can be solved faster on a quantum computer than you can do on a classical, by classical here, I mean not quantum computer. And I should emphasize, this does not mean that you can solve all problems faster, but there are some problems for which it's been shown that quantum computers are faster than a classical computer can ever be. And in particular, Turing machines can simulate a quantum computer, but it's not known if they can do so efficiently. And so what this means is it means that there are still some tasks. One famous example is integer factorization, that it's not known if they can be performed efficiently on classical computers, what we're used to, but it's known that they can be performed efficiently on a quantum computer. And this motivates us to study what are the possibilities and the limitations of quantum algorithms. So in particular as you might imagine, I'm interested in algorithms, quantum algorithms for optimization. So a large part of my time is devoted to trying to find quantum optimization algorithms that are more efficient than their classical counterpart. And so to do this, there are mainly two strategies. And one strategy is to try to quantize, here quantize means to make quantum, some existing optimization algorithm. But alternatively, one can try to design new algorithms that are really based on quantum mechanical ideas that don't have a classical counterpart. And I should note here that even though I'm really focusing on optimization, the same is true for other areas of data science. In particular, there is a lot of interest in quantum machine learning algorithms. And many of these areas are still very new, so there are still very basic discoveries that are being made. Now, when it comes to quantum optimization algorithms, some well-known classical optimization algorithms have in fact been quantized. There has been work on interior point methods, on the multiplicative weights update method, even on the simplex method, and this is something that I devote a lot of my time to. But as you might imagine, this is a very new and very exciting area, and so making progress is something that often turns out to be very difficult. At the same time, it's clear that this potentially has a huge impact on the theory, but also the practice of data science. And for this reason, I'm extremely excited, and this is where I spend most of my time in trying to understand possibilities and limitations of quantum algorithms for a variety of tasks, specifically optimization, but in general other tasks that come from data science and in an industrial environment. And I think this is all that I wanted to tell you. Thank you very much for listening, and enjoy your data science masters.
So hello everyone, I'm Francesco Tudisco from the GSSI, the Gran Sasso Science Institute in L'Aquila in Italy. And broadly speaking, my research interests are in computational data science. And today I would like to tell you about a problem that arises in this area, which is the problem of link prediction, and how can we actually approach this problem using computational tools. So when you want to work out data sets, you want to do some data analysis from a mathematical point of view, one of the most fundamental tools are graphs. So graphs are mathematical objects, very, very combinatorial objects, if you want, that are just made out of nodes, so a set of points, set of nodes, and a set of edges or links that connects these nodes. So it describes sort of like relations within these nodes. You see in this figure, for example, we have these dots that are the nodes and links that connect them pairwise in this way. And you can have an undirected graph, which is typically modeling connections that are taking place in both directions. For example, like a friendship relation between two nodes that are, for example, two human beings. Or you can have directed graphs where connections have a direction. Like, for example, in the case where we are modeling, for example, the movement of some good from one region to another region, where these regions are denoted by the nodes in this graph. And in general, graphs or data structure that can actually be described by graphs appear in data science very, very frequently and in very different ways. So I would just like to give you some examples that you probably have already thought of, and I mentioned some actually just a moment ago already. But just to give you an idea of how broad is this setting. So we can have, for example, social networks, which can model, for example, a group of people, group of students in a class, and these are the nodes, and then we can model with edges exactly friendship relations within these people in this class. So we have or mutual acquaintances or times that these people have been in contact with each other. And this is also, of course, the case of large data sets like Facebook, for example. That's also, if you take the social network itself of Facebook, this is actually indeed a big graph where each page or if each account is a node, and friendship relations between users are actually modeled with edges. Then we have, for example, the setting of road networks and the context of graphs. When you want to model a system of roads in a city, for example, you can do this by assigning to each intersection between roads a node, and then modeling through the edges that connect these nodes the road structure of the city. This kind of networks are particularly special because you see here, unlike the previous case, we do have a sort of a geometrical underlying structure, because the nodes, the street, they actually live on the ground, right, on the surface of the earth, and so there is a geometry location that can be added to the network. There are the situation of a citation network or collaboration network in this case, where nodes are authors, for example, and you have edges between them if these two authors have co-authored some paper, they have done some work together. And this is a network of co-authorships among some authors in the network science literature, and the dots are bigger when that author has many collaborators. So these are proportional to the number of collaborators that the authors have here. And we can go on more and more, of course. There are really, really many examples. I just would like to give you just a few more, maybe two more, where the situation is slightly different. Instead of having a dataset that is already itself a graph or a network by sort of definition, if you want, there is the situation where, for example, we can build a graph ourselves from a just given data set. And we do this by looking at sort of similarities or features that data points in our data set have in common. So one typical example is this similarity graph indeed. Here, for example, I'm thinking of a set of images that are actually digits, handwritten digits like this, the number 8, number 1, number 4. And what we do is we embed these digits in a vector in our N, and then we look at distances between these vectors, and we add an edge between two images that are the nodes of our graph if those two images are close by enough in this space. So you see, this is more or less to say, this drawing here is to say that we sort of draw like spheres around each image that have the radius as the distance that we are interested to measure, and all those points that fall inside this sphere, we add an edge for those. And so that's something that you get. That's another example. And final example is again related to images. This is called affinity graph, where we have two images and we have two sort of mark points here, like important points that we want to take into account for some reasons. And what we can do is we build graphs where the nodes in the graph are actually these points that are representing the same object in the two images, and we try to match them with affinity properties, and that also gives rise to a graph. So now this is just to give you an overview of the fact that graphs really appear everywhere. And now I would like to go a little bit more into the details of what link prediction is, what the problem of link prediction is. So, so this is a quite typical problem that arises in the context of data science and in computational data science in particular. And the setting here is that we have a graph that we have modeled from a data set in one of these different ways that I have just discussed, or other ways. And then what we want to do is, okay, we want to predict whether or not certain edges that are not there, there should actually be there. And the situation why we could be interested in doing this is typically because of two reasons. One is that our data set is actually changing in time. And so, for example, we have measured our social relations in Facebook today, and we don't want to do this measurement again tomorrow, but we would just like to say, okay, if this group of people are friends, probably that other person will soon be friend of them as well. So there would be a new edge there. And so we would like to predict that without having to buy again the data set from Facebook. Or another situation is where we are measuring stuff and we're measuring a data set and we sort of know, we expect that there is some noise in this measurement that we're doing, and this noise can actually lead to some missing edges. So we would like to, fix the measurement that we have done, repair the noise that we have created by adding some missing edges. And we want to do that in a clever way. Now, how can we do this in practice? So one idea could be, okay, let's take all our missing edges in the graph. So we take any 2 points, any 2 nodes, and we consider only those pairs of nodes that don't have an edge. And then we can say, okay, let's assign to this missing edge a score. And this score should be sort of like giving us a probability that that edge that is not there should actually be there. So the larger is the score that we assign, the more likely that edge should be in the graph. And then the point is, okay, how can we compute in a clever way this score, the link prediction score? So one possible idea, which is one of the most naive, one of the first one that came out, is to say, okay, let's compute the distance for a given node, input node 1, for example, or node U. I compute for all the nodes that are not connected to U, I compute the distance, the shortest path distance in the graph between that node 1 and the other nodes. So, for example, in this case, we look at node 1 and we look at node 6, for example, we compute the shortest path distance. So what's the shortest, the smaller number of edges that I have to cross to go from 1 to 6? In this case, it's 1, 2, and 3, so the distance is 3. And then I do the same thing for all the missing connections between one and the other points. And then what I do, I say, okay, I can imagine that nodes that are closer by, according to this distance, are more likely to be, missing an edge. They're probably somewhat similar, and so probably there should be actually an edge there. So what I can do, I can rank or assign a score to these missing edges by looking at the reciprocal of these distances and rank the missing edges according to this reciprocal. So in this case, you see the distance between 1 and 5 is now 2, and so I assign a score 1/2 to this missing edge here, the edge 1, 5, and I assign a score 1/3 to the missing edge 1, 6, and so forth. Then I order this scoring, and if I am interested in guessing whether 3 missing edges, I would take the first 3 entries in this list. Right, so that's one idea. Now let's see a more mathematically robust and meaningful model to measure these scores. So the idea of this other model is based on this concept of a random walk on the graph. Now, very briefly, what are we going to do? So we're going to sort of model a person that ideally is moving along the graph, following the edge structure of the graph, the one that we actually have, and choosing to move along one of these edges with some probability. So for example, we can say that at the node, if we are at some time at node I, we can move only following the edges that outgo from I, and we choose to go along one of these edges with a probability that is basically 1 over how many edges do we have. So basically we choose at random, we throw a dice with as many faces as the number of outgoing edges that we have, and the number comes out, we say, okay, I go along that edge, right? So if Pij is this probability, so the probability that if I am at node I will go to node J, then this probability can be written like this, right? It's 1 over how many neighbors the node I has. And of course, it's probably 0 if I has no neighbors. So I cannot move from there anymore. But that's the concept of a random walk that we are interested in. And that's in particular the random walk that we are going to consider for this problem. And now what is the idea? How can I connect this with ranking missing edges? Well, what I can do is to say, okay, let's consider now a pair of nodes that are not connected, node U and V, and let's compute what is the expected number of steps that a random walker that is moving in the graph following this random walk would take to move from point U to point V. That is, again, sort of measuring a distance between these 2 points. So how far, in a way, is a U from V? And so we can then measure the similarity or the score of the missing edge UV by looking at the reciprocal of this number. So that's another score, different from the shortest path distance, which is the one that we're going to, that we're interested in. I should say that this score has a little drawback. And the drawback is that, you see, if we are looking at the specter point, number of steps from point U to point V, what happens is that we start, moving randomly in the graph, and then very soon we end up quite far from U, because we start in U, we move, we end up very far from U. And so what happens is that we sort of lose track of what is going on in the neighborhood of U, which is typically where actually we're interested in looking for missing edges, if we're interested to look at missing edges for the point from starting in U. So what people typically do is to modify this random walk slightly by considering this restarted random walk, or also called rooted PageRank random walk, where basically what we do is just say, okay, instead of just deciding to move along my neighbors, what I say is, okay, with probability alpha, for some alpha, I move following these neighbors, as I was doing before. But with probability 1 minus alpha, I restart my random walk. So I jump back at the very beginning, node U, where I started this random moving in the graph. Right, so this is the restarted random walk, or rooted PageRank random walk. And that's what we're going to consider. So overall, how are we going to measure the score of a missing edge, where we look at the potential missing edge between node U and node V, and we compute the expected number of steps that the random walker that moves along the graph with this restarted random walk would take to go from U to V, and then we take 1 over that. Okay, so that's the idea. Now, there is a big question here. Okay, we would like to compute this expected number of steps, but how can we do that? And that's where the computational aspects come into the game. And in particular, you will see that we can compute this expected number of steps by using linear algebra and numerical linear algebra in particular. So we're going to use matrices. But so far we haven't seen a single matrix. So where do the matrices come into the game here? There is a very fundamental tool for mathematics of data science, which is this object called the adjacency matrix of a graph. So if we have a graph, we can describe it in a unique way by just defining a matrix, whose entries are just zeros and ones. And basically this matrix is made like this. The columns and rows are nodes, so correspond to the nodes, and the entries of the matrix correspond to edges in the graph. So basically we put a 1 in position, for example, here, 1, 4, if there is an edge that connects nodes 1 and 4. Then we put the 1 in position 2, 3, if there is an edge that connects the nodes 2, 3, and so forth. And you see that because here we have undirected edges, which means that we actually have the edge from 2 to 3, but also the edge from 3 to 2. This matrix is symmetric, and each non-zero entry appears twice in this matrix here. And so the non-zeros, you see, correspond to the edges in the graph. And I actually colored them here, corresponding to with the same color of the edge that you see on the left-hand side of this formula. And of course, we can have also directed graphs where the situation is slightly different in the sense that we don't have anymore 2 non-zero entries for each edge, but we only have 1. And you immediately see that these matrices are very sparse, meaning that there are a lot of zeros and just very few non-zeros. And this is a very important property that is the one that allows us to make computations in an efficient way with these matrices, even though we have huge data sets. So how can we use these matrices to compute the rooted PageRank link prediction score? So that's the idea. so I'm sorry if you're not familiar with matrix notation, it's not really important. So but just try to follow me here. This very high level idea. So what we can do is you can think a moment at this probability that we were discussing to go from node I to node J as 1 over the neighbors of the node J, and you can, if you think a moment, you realize that you can actually write down this probability as in terms of this adjacency matrix. And then what you can do is you can write this big matrix here, which is called transition matrix of the restarted random walk process, which takes into account for this restart that we were considering. Now, this is again a matrix which can be written in this way, which is sparse and defined in terms of the adjacency matrix. And then what you can observe is that if you want to compute this PageRank score here, so this expected hitting time, you can do that by solving a system of linear equations that involve this matrix here. And in particular, you can do it by solving this system of equations here, which is also called an eigenvector problem for the matrix PU, where our unknown is the vector x here. And then what we do, basically, we look at the entries of this vector, and those entries are going to give us these numbers that we are interested to compute. And so you see that this is a typical problem that appears in numerical linear algebra, but where we have to exploit the graph structure and the data structure. And that's one of the examples of computational data science. How can we solve this efficiently? And we actually can do that, and we can do that on very large networks. So I would like to conclude with just one example to show you that actually this whole mathematical construction actually helps. So what you see here is the comparison between what happens using the PageRank and what happens using the shortest path distance. So here we are taking two networks. This is, I think, a citation network, and this is a social network. And we computed how many of the edges that we predicted using those models are actually correct edges that should have been there. So basically, we take this network, we remove initially some edges, and then we try to predict them back. And what you see here, this is the ratio between the correctly predicted edges using PageRank and the correctly predicted edges using the shortest path approach. You see that this ratio is very often quite larger than 1, even almost 4 times. So it means that the PageRank is predicting 4 times better than the shortest path approach. Okay, so with this example, I would like to conclude. I hope you found this presentation interesting. And if you are interested in more details, well, you can have a look at my webpage or some of these papers where I've been working on topics related to the link prediction and how to compute these things in an efficient way. And this said, I thank you very much for your attention, and yeah, have a good day.
Hi everyone, my name is Lamberto Ballan and I'm a professor in computer science at the University of Padua. Today I will present the new curriculum on machine learning for intelligent systems within the data science master program at the University of Padua. Data scientists need to understand and develop models for dealing with big data. Machine learning is one of the fundamental tools at the core of data science. This curriculum covers all the fundamental concepts and tools in machine learning that are required in order to develop machine learning driven systems. The curriculum is specifically designed to accommodate both graduates from computer science or engineering bachelors, as well as graduates from other disciplines, such as math, statistics, and so on. Before describing the curriculum, let me spend a few words about the artificial intelligence or machine learning revolution that we are observing these days. AI is really having an impact in our life, and you have probably daily life experience with many of the most successful applications in AI. One example is machine translation. If you use Google Translate, you can see that nowadays it works pretty well. The reason why it is working well now is because of machine learning and natural language processing. But probably you have also experience with speech recognition, and you can see that now also speech recognition is working pretty well. So probably you try to ask questions to your Siri or to Alexa in order to start a song, for example. Or you can ask questions to chatbots, such in many systems that you can see in several websites. But another area where you have probably daily life experience of successful AI applications is the area of visual data processing, so visual recognition. And this can be the case of facial recognition, where you use automatic systems that are able to detect your face in order to build automatically a gallery from your photo. Or also advanced systems such as smart driving systems or self-driving cars, where you have cameras that are able to detect objects in real time. As well as many other domains where imaging techniques, such as in healthcare, for example, are really helping medical doctors to understand pictures of in order to assist their decisions. But all these AI applications are really based on machine learning. So if AI is the science to make things smarter, the reason why we are talking about an AI revolution is mostly because of machine learning. And machine learning is, the goal of machine learning is to build machines that can learn. So all these successful stories are actually based on machine learning, and a particular class of machine learning algorithm that is deep learning. And so all this recent breakthrough in AI are telling us the same story. So you have big data, you have and you use data science and machine learning in order to build intelligent systems applications that are able to make data-driven decisions. What about then our machine learning and intelligent system courses? Well, our courses in this context put a strong emphasis on, first of all, statistics and applied mathematics, on machine learning algorithms and tools. So all the concepts that you need in order, and the main technologies that you need in order to build these intelligent systems, these applications. But at the same time, we have also an emphasis on cognitive sciences and the impact that these data-driven systems have in law and society. Who are the students? What's their background? We welcome students with a good background in computer science or engineering, computer engineering, and all the bachelors in ICT, such as telecommunication automation, as well as students coming from mathematics with a good background in mathematics, statistics, and physics. Our prospective students should have the willingness, first of all, to study both math and computer science, as well as apply this knowledge in a broad range of domains. So you should expect, this is a multidisciplinary program that will enable students to master, first of all, machine learning to develop intelligent systems, but also to be aware of the connection between these tools, all those tools, and cognitive sciences, and their impact on law and society at large. Our students will have, should expect to see many course projects, and these will allow students to develop analytical and management skills. This is done through hands-on experiences. But at the end of the program, thanks to our partnerships with companies and research institutions, they will have also the opportunity to focus on exciting data science application and research. So in a nutshell, our graduates will develop a deep knowledge of machine learning and cognitive systems, the ability to deal with computational and learning challenges that are behind all data-driven systems. And this will lead us to have students that have an effective and attractive professional profile, and this usually gives the result of this is that they have an excellent placement in the job market. And this is because companies and research institutions dealing with big data, and this could be the case of companies working in ICT or transportation and logistics, finance, biology, and healthcare, so almost any domain, are really looking for people having these skills. So the opportunities are really countless. What's the curriculum structure? We have 4 main pillars. So your mandatory courses are clustered around these 4 pillars. So first of all, mathematics, where you have courses such as stochastic methods and optimization for data science. Then you have a strong foundation on statistics, in particular on statistical learning. And in this particular curriculum, as you can see in this slide, we have 3 mandatory courses in the core courses in the area of machine learning. Finally, we have 3 courses that are in the area of biology, economics, human and social sciences that are providing our students the opportunity to have a deep understanding of the connections between cognitive sciences and law with machine learning-based systems. Then students will have 2 optional courses, one to pick, one in the area of computer science and one in the area of biology, economics, and human and social sciences. And finally, 2 elective courses that can be selected from almost any domain. What's the structure of the program? Well, first of all, as I was saying at the very beginning, this program is specifically designed also to accommodate students from computer science and computer engineering. So for this reason, as you can see in this slide here, and this is the main peculiarity with respect to the other curriculum, you don't have at the first semester the course of fundamental information systems. And the reason why we haven't, you don't have it here is because this is usually something that has been already covered if you come from computer science or engineering. But actually, as you'll see later on, we can also, if you come from other area, you can also select this course as from your elective courses. So the structure in the first semester is based on you have statistical learning and machine learning. Then in the second semester, the second part, and then you have the fundamental courses in mathematics, such as stochastic methods and optimization for data science. And then you have, particularly in the second semester, all the other core courses in machine learning. Then, as you can see in the first semester or the second year, you can pick the electives and the optional courses. And finally, in the second semester, you can work on your thesis and on a full-time basis. And this can be based on your internship in a company or a research institution. The structure of the curriculum can be adapted to your background. And so in this case, as you can see here, if you don't have a strong background in computer science, you can postpone the courses in the cognitive computing and law and data to the second year, and you can focus at the very beginning on the foundation of information systems as well as it is done in the other curriculum. And so as you can see here, cognition and computation law and data in this case is postponed in the second year using some of the credits that are usually assigned to your elective. So that's basically it. If you have any questions, please ask at the end of this session after the presentation of all the other curriculum.
Welcome everybody, my name is Francesco Rinaldi and I'm here today to describe you the new Mathematics of Data Science curriculum for the Master of Science in Data Science at the University of Padova. So let us start this brief presentation. First of all, believe me or not, mathematics is really ubiquitous in data science. And behind a large number of data science models and methods, there is plenty of mathematical tools that make things work. So data scientists, they really need to properly understand and develop both models and methods for dealing with those data. So what about mathematics of data science? Well, this curriculum qualifies students to build and analyze structured models for the representation of concrete applications, to properly choose and develop methods for the handling of those models, to get a deep understanding of theory techniques and mathematical theory for data analysis, to properly combine and redevelop all those tools in order to solve complex real-world problems. So the courses we have in this curriculum, they all put an emphasis on notions coming from different fields like statistics, optimization, machine learning, theory of big data representation, and all of these notions are nicely merged together in these courses. So, of course, we warmly welcome students with a good background in mathematics, statistics, computer science, but what you need to keep in mind is that prospective students should just have the willingness to study mathematical theory and to apply their knowledge in the practical management of big data. So what we really expect from students is that they have an interest in using mathematical tools and tailored algorithms for the analysis of data. So what you should expect from us instead. The curriculum is conceived as a multidisciplinary platform that enables you guys to handle models and methods coming from statistics, machine learning, optimization, and to properly understand the way all those tools are intertwined in big data applications. There's going to be plenty of projects and homework that allow you to develop project management and analytical skills in the fields that you like the most. And finally, the partnerships that we have with industries and research institutions will enable you to implement mathematical techniques in the solution of exciting data science applications. So who you will become after this trip? After this 2-year program, you will be able to represent, compress, and storage each dataset, to develop suitable model to recognize and analyze data, to properly understand the methods for the handling of big data models, to properly tackle advanced problems and applications based on current research. What about employment prospects? Well, there is a good bunch of companies and research institutions that usually deal with big data, and they need to handle and properly analyze a huge scale of data. And this happens in finance, transportation, communication, biology, just to list a few of them. And what they usually expect is that you have a strong mathematical background that enable you on the one side to approach real-world problems using computational analysis, and on the other side to properly understand the mathematics underpinning these big data. Our graduates, thanks to the deep knowledge of mathematical theory and the ability to deal with the computational challenges behind data-driven systems, they really represent an effective and attractive professional profile that surely get an excellent placement in the job market. So let us take now a look at the list of the mandatory exams that we have in our curriculum. And these exams somehow represent the foundations of the curriculum of mathematics or data science. As you can see, we have a good bunch of exams in mathematics, statistics, and computer science, and they will give you a good bunch of practical and theoretical tools for proper handling and to properly analyze the data. Finally, you will also have an exam in biology, economics, and human and social science, and you'll get the chance to use those tools in practice. You further have 2 recommended courses that you can pick in this list, and 2 elective courses to complete the study plan. Okay, so let us take a look now at the structure of the curriculum in the 2 years. So in the first year, first semester, you will have the first part of statistical learning and machine and deep learning, fundamental of information systems, and you can choose, depending on your background, between stochastic methods and the advanced course in high dimensional probability for data science. In the second semester, you will have statistical learning, the second part, and the second part of machine and deep learning, the optimization for data science exam, and mathematical models and numerical methods for big data. Finally, you will get the chance to choose your first elective course. In the first semester of the second year, apart from the 2 mandatory exams that you are left with, you will be able to choose between one of these courses and one of these courses. And finally, you will pick one more elective course to complete the exams. The second semester will completely devoted to the internship and to write down your thesis. After you are done with that, you'll get your final degree. So, if you have any question, you are free to ask after this presentation.
Hi, I'm Damiano Piovesan. I will give you today a brief introduction of the curriculum of Biological Data Analytics of the course of Data Science at the University of Padova. Well, we are now living in the omics technologies, which open new frontiers in biomedicine and biotechnology. In fact, modern life science is based on high-throughput experiments, which generates data, which requires interpretation. And of course, this interpretation can be possible just adopting computational technology, advanced statistical analysis, and mathematical tools. In the market, there is a great need for specialists and analysts in research institutions, hospitals, pharma, and diagnostic companies. Well, this is an example of the protein folding problem. So the problem is, starting from the sequence, determine the three-dimensional structure of protein. Historically, this problem can be solved adopting a brute force approach, for example, simulating physical forces and then generating the force field and the movement of the atoms until the three-dimensional structure is obtained. Well, with the advent of machine learning, and specifically very recently with the adoption of deep learning, the AlphaFold algorithm can generate the three-dimensional structures, let's say, from the sequence in hours instead of years of calculation necessary for molecular dynamics to get a reliable solution. And the new algorithm has been developed by the Google DeepMind lab. Another example is what is called precision medicine, which will represent the future of treating a disease. In fact, at the basis of precision medicine is the fact that a disease should be understood at the molecular level. And so knowing the molecular mechanism underpinning a given disease, we will be able to target precision medicines against the cause of the disease rather than just simply treating the symptoms. Well, there are several companies already working on that subject. One example is 23andMe, which scans your genome just looking for specific locations, and with that is able to say something about your ancestry or something about your traits. But scanning the entire genome, it will give you the opportunity to also tell something about genetic diseases or tell you something about optimal dietary profile of your organism or your genome, which is very promising to improve the health and to give an opportunity to cure several diseases which are actually very relevant for the society. What about the biological data analytics courses? Well, it is a mixture of math and bio courses. The math part is focused on statistics, applied mathematics, but also machine learning algorithms and tools. The biological part is concentrated in molecular and cell biology, and computational biology and bioinformatics. Prospective students' background can be computer science, computer engineering, mathematics, statistics, physics, but also we accept people coming from biology, medicine, and related bachelors, maybe with an emphasis on some additional course on math and statistics. Prospective students should have an attitude on both basic science and computer science. They should enjoy knowing more about biology and medicine. What we expect from students: tackle computational biology problems in a scientific, evidence-based manner. So you are working with real biological data, so this is a very important point. And they will gain experience working in a true multidisciplinary mindset. So mixing biology and math gave this opportunity. And also one important thing is the effective management and exploitation of high throughput experimental data. In addition, students will have the opportunity to perform real lab experiments and understand molecular data and how are they generated, which is very important to understand which are the problems to generate some specific kind of data. What to expect? Well, mathematical and computational methods in computational biology and bioinformatics, advanced machine learning, optimization, and algorithms to model biological phenomena, analysis and interpretation of a large dataset, those, of course, coming from the omics technology, and fundamental aspect of cell biology. Our graduates will have basic knowledge of life sciences, an ability to deal with omics data, and ability to model molecular system, which is an effective and attractive professional profile, and there is an excellent placement in the job market. So employment prospect, for sure, biology and healthcare, both in the companies and the research institutions, also drug design in pharma companies, precision medicine, diagnosis, and so on. So this is the structure of the course. There is a number of biological exams, for example, structural bioinformatics, biological data, but also there is a number of mathematics, statistics, and computer science exams. We will give you a background, very strong background in machine learning and mathematical tools necessary to approach the interpretation of biological data. Then there will be other 2 optional and 2 elective courses from computer science or biology, and the elective will cover 12 CFU. This is the structures of the course for the along the 2 years. So in the first semester there will be a focus on statistics, mathematics, and machine learning. In the second semester, from the second semester, we will be starting to introduce to more biological exams, introducing bioinformatics, molecular biology, but still focusing on the statistics and data analytics courses. On the second year, again, there will be a number of biologically related courses, plus 1 course to be chosen from bioinformatics, law and data, mathematical cell biology, and omics in human disease, and another course chosen from human data analytics, game theory, and network science. So at the end, on the second semester, an internship and the thesis will you the necessary CFU to complete the course. This was pretty much what I wanted to say about the course. I hope you will enjoy to participate and to choose this course. Bye.
This is a short presentation of the curriculum in cognitive, social, and economic data analytics. The curriculum prepares data scientists to understand complex issues in cognitive, social, behavioral, and economic sciences, and provides methodologies that allow extracting relevant information from cognitive, behavioral, social, and economics data. This curriculum has to do with issues like prediction of personality, preferences, user behavior, digital marketing, lie detection, cognitive behavioral data and security, the use of machine learning in psychology and neuroimaging application, human-computer interaction, brain-computer interfaces, wearable systems for human biodata acquisition, neural networks and computational modeling of human cognition and behavior. These are just a list of topics which are covered in the curriculum. Just to give you an idea, go back to the so-called Cambridge Analytica data scandal. This scandal, which was on the cover pages of all the newspaper in the world 2 or 3 years ago, was about collecting data from Facebook and trying to predict personality and political orientation of people and voters in US in such a way that only people who were uncertain were targeted by the Trump campaign. Another example is how to improve safe driving. For example, this is a system which can identify emotions from faces and therefore can try to predict and alert a driver about his reaction while driving. The know-how which is required in this field is statistics, machine learning, economics and finance, psychology, which includes cognitive science, behavioral science, neuroscience, and social science. The student which can benefit from this master degree are the students with a background in cognitive science, economic science, statistics, and computer science, and they should have an attitude to apply computer science and statistics to psychological behavioral problems in general. This curriculum is conceived as multidisciplinary and enables students to handle models which come from statistics and apply them in topics like business, marketing, psychology, cognitive science, neuroscience, and so on. The student will be presented during the curriculum with real-world application in the field and will work on a project and trying to develop their skills in handling this sort of problem. After 2-year program, the student can choose between going into research or apply to companies that require this sort of data, socially oriented data science, data analytics. So the basic knowledge will be acquired on economics, social and behavioral science, and the ability to treat this data using statistics, data analysis, machine learning, and this leads to an excellent placement in the job market. The issues, the topics which will be acquired during this curriculum are mathematics, statistics, computer science, biology, economics, and human and social science. Within computer science, they will develop skill handling, deep learning, vision and cognitive science, knowledge and data mining, human-computer interaction, and they can choose among two courses. This is the organization for the first year. They have to take courses in statistical learning, foundational information systems, stochastic method, machine learning, statistical learning. This is the second semester of the first year, and the second year again it is will cover these topics which are listed here in the first semester. One in the second semester they will work on the project and have an internship.
So, hello everyone. So we should be live now. So this is the second part where we have a live session where we discuss the entry requirement. And so this is the second part. We also discuss how to apply the internships, and also we
Laura, sorry, you should unmute yourself.
Oh, sorry. Okay, restart. Thank you very much for inviting me to this presentation, and as a representative staff of the Teaching Activities Office. So I'd like to start my presentation with the first slide. Sorry. Okay, restart. Thank you very much for inviting me to this presentation, and as a representative staff of the teaching. Sorry, can you hear me? Because I heard my voice.
Yes, we do.
Okay.
It's just the audio coming through the YouTube.
Okay.
It's delayed.
Okay, perfect. So my first slide is about entry requirements. What are these short lists, but most important is exhaustive. You must have this entry requirement. So 30 ACTS in specific following this area, mathematics or informatics, computer science, or other. This is the short list. You must have a degree classification at least 85 points, and a B2 level of English, but only reading and listening. No certificate are required, and obviously you must have a good curriculum in mathematics and computer science. The second slide is about the application. What you have to do if you have an Italian bachelor degree or an international bachelor degree. If you have an Italian bachelor degree, you have to follow the admission call for application, which contains all information needed to apply. The avviso di ammissione, this is the link, is about to be published. You have to read carefully and to submit your application. If you have an international bachelor degree, if you are a student, obviously international students who wish to pursue the education in Italy are always welcome here at the University of Padua, and there is a specific link. This is Dream Apply, and you can submit your application here. And please be careful, because the second call will close on 7th July. What kind of international program the master degree offer to Italian or international students who are enrolled in data science program? The University of Padua has been promoting student mobility for over 30 years, and all the students have the opportunity to spend a semester or a full academic year at a partner university, either to study or to carry out research. The following list is not exhaustive, but these are the main program. Erasmus program, which enables students to spend a period abroad in an European university. These are the links. Erasmus Plus for studying, and Erasmus for traineeship mobility. SAMP is very similar to Erasmus Plus program, and is a program that allows students to spend a period in a partner university in Switzerland. And at least the Ulisse project is a new project of the University of Padua, promotes students' mobility in non-European countries. And last but not least is about the program fees. For this academic year is about 2,000 euro divided in 3 installments. But no worries, no panic, because tuition fees can also be reduced significantly. Here there are some links, and check this link. The following pages summarize all the possibilities students have to apply for a reduced fees. Here, particular fee waivers, there is a list of the funding opportunities. And also you can reduce this amount, could be reduced during the year on the basis of your ESA. So no worries, that is about 2,016 euro. No worries. So thank you very much. And for all the questions, drop us an email to data science. And so I leave the floor to Professor Rossi for the internship to explain you what are the internship in data science project. Thank you so
Laura.
much.
So thank you so much. So the last thing that we discuss, and then we leave the floor to you, to your questions, is the internship. So basically, what is it, first of all? Is a period of study/work at a company, industry, research center, research lab. So when we think of having it, it's basically at the second semester of the second year of this master's degree. So usually our students is not mandatory, but you may have it, and we of course we welcome that. The student may carry out an internship period between lasting between 6 and 8 months. And they also usually combine this internship period together with the final master thesis. Those are often combined together, and so the final thesis will contain work that is carried out during the internship. So you can proceed, please. So why is that?
Sorry.
If you can go.
Okay.
Why you should be deciding to go for an internship is to get in touch with the work environment, to start, knowing and thinking how companies do, to build up new skills, new technical skills, but also soft skills like interpersonal skills and relationship with clients with the companies and stuff. To apply data science algorithms to practical problems and to create connections and synergies that we found them to be very valuable to the student, especially for their future occupation. So basically, we offer this opportunity for the student to get in touch with the work environment before they graduate. So, and also to carry out the master thesis on practical problems that are basically offered by our industrial partners before they graduate. So this is an advantage in terms of occupation for sure. And this is part of our program. If you can proceed. So this is just a snapshot of a few partners that we are in touch with. Those are, so we are basically in touch with many. Some of them are collaborating with our professors, with the data, closely with the data science professors, and those partners are copied here for you. So what we do, once a year, we organize a day when the companies meet the students, in order to present their project opportunities and also their needs and also their internship opportunities to the students, so they can interact directly and talking to a representative from the company, and they can set up an appointment and then discuss towards going for finally an internship with them. So this is one possibility that we offer. So we have this sort of basket of companies that we are closely in touch with, that we communicate daily with, and we can offer to the student. But this is not the only way in which you can pick a company for your internship or a research center also, because you see here we have Max Planck Institute, we have the Lazzaro Spallanzani Research Center. So it's not only about the industry field, it's not only about the company field, but it's also about the research field. So you can decide what you want to do. Okay, can move on, please. And the main steps are very simple. You first of all, you need to identify a partner for the internship if you decide to go for that. It could be using our website. It could be from the University of Padua database. University of Padua, through the career office, they have a large number of partners already involved, and they collaborate with the University of Padua at large, and or any other means. So you may know a company on your own, and you may think that this company is good for you for this internship of the data science within the data science degree, and then we can talk and we can decide whether this is the case. If we all agree, then you can for sure also pick a company of your choice. But we need to analyze, of course, each is on a case-by-case basis, those cases. You need to identify a company supervisor, you need to identify a university supervisor, and also you need to work on a project that is related to what you have been studying during the courses in the data science curricula that were presented before. So the internship should be technically related to what you have been doing within the degree for sure. And this will be, whether this is the case, will be ensured by the university supervisor, whose function is to make sure that the work that you are carrying out, the technical work, will be suitable for this type of degree. Okay, so we can move on, please. Next slide. Yes. So as I said, there are, now I'm not going to bother you anymore. If you want to find out more details about the steps that are required, they are not difficult. Basically, you need to identify the partner, first of all, to get to know your partner, your company, and to talk to them. And then you need to talk to a university professor. We also have a video in the website from Gilda Rota. She's the responsible person from the University of Padua Career Service. You can take a look there, and she will. This is coming from the presentation that she gave last year in December in 2019, before the COVID. And we had this nice day where we invited companies, and she explained carefully all the steps and opportunities that you may have, even beyond what I'm saying right now. Okay, it's not a difficult process, and yeah, if you have any question, then we also have the email that you can follow. At the end of this live set, you will find the email that you can use to contact us, and either myself or Laura will be helping you out with this task. Right? Can move on. So this is about the new website. So yes, we just have a brand new website. We are still updating it and also refining it. So, but the thing is, we are there. In this website, you can find a description of the curricula, the admission procedures, and the links also. Some useful information for the students, like the canteen at the University of Padua, our services, our libraries. You can find information about the internship. Also in the internship page, we are publishing the videos from the companies where they introduce themselves. And also whenever a company has a new project and has a new proposal for an internship, what we do from now on, we will be publishing this opportunity there in the internship page. And then we have some news and events. So this is a good way to stay in touch and to see what we have to offer, and also what we do. If we have I don't know, any seminar or any event, then this will be publicized through the website as usual. Okay, so that's all. I will say that next slide you should have the contact. Yes, so this is the email that you should be using to contact us for any issues related to application or internship procedure or Erasmus procedure. Then we'll give you an answer for sure. And also the website that I was talking about before is over there. Okay, so now we can proceed with your question. So I will say there was a question on top about the I would direct this question to Francesco Rinaldi, I believe, if he's available. This one is on a student who's not maybe so good in programming. If this is going to be a problem with the course in mathematics of data science.
I mean, I think having a good background in computer science is always good to carry out this curriculum. But I mean, as long as you have the willingness to study in-depth computer science and mathematics, and you have, I mean, an interest in those two topics, then I'm pretty sure you will be able to deal with the exams in computer science. Even if you don't have a very good background. Anyway, there are some minimum requirements that you need to have in order to apply. Anyway, so if you if you are able to get over those requirements, then you can surely apply, and then you can surely, by studying, get to the end of this curriculum, I guess. I hope the answer was...
Yeah, I believe, if I may add, thank you so much, it's not going to be a big issue. Of course, some basic exposure to programming languages such as Python, like a very simple crash course on that would be beneficial, at least to know what it is and to be able to program a few simple lines of code. But anyway, our courses, I believe most of the courses that are dealing with programming, they also have some introductory material for you, and you will be learning progressively how to use the tools that are required, especially the Python language. On my side, on the machine learning side, I believe is very important. But I don't think it's a very strict requirement. You can learn as you go, I believe. Then there is another question from Hong Kong. This guy studied mechanical engineering as an undergraduate, and is asking whether what he should be learning in this summer to well prepare himself in the coming semester for the Master of Science year. Okay. Okay, and then it's also wondering about the exchange opportunity for master course student. Okay, so for the topics, you can go to the website. You see the admission page. We have some information about the requirements. So what we expect from you is a general knowledge about algorithms, about informatics, about linear algebra. So all the fundamentals of, mathematics, algebra, and algorithms are well accepted and recommended. And there you can find a list of those. Nothing advanced, I believe. So it's a typical things that you are studying as an engineer should be sufficient. We also have in the admission page the number of credits that we expect from you in all the different fields that in the mathematics and programming and other fields that we evaluate during the selection process. So you can have a look. If you don't understand, you can write to us, but I believe the requirements are mild, so that we are not so strict. And also what is going to be offered and studied by an engineer is usually sufficient. It should be covering quite decently what you need. Okay, if you guys want to add something, the other professors. Okay, if nothing is going to be added, I would like to ask Laura on if she can comment on opportunities for incoming internships, like coming here through an Erasmus or some other program, because there are students who are wondering whether they can come here through exploiting some program to study, although they are not enrolled here, to study in the Masters of Science degree with our students.
Yes, of course. He had to apply in an Erasmus program, or not only for European Erasmus European project for I don't know where he comes from, Russia maybe, or other countries. It depends, but incoming students are always welcome at the University of Padua. He had to apply in his university, or maybe in an agreement. I don't know what he wants to do in his future here in Padua. He can write us, and we find a solution. Surely, there's no problem.
Okay, so there is another student, Farouk, is wondering about, he would like to carry out his own master thesis with us. So he's basically enrolled somewhere else, probably in Russia, he said, if is this the case, and he would like to come here for the master thesis. So I'm sure this is possible. You need to first pick a professor that you will be suitable for you, and then probably if you write us, we can put you in touch with a suitable professor, and we'll see if there is mutual interest and mutual agreement. Why not? You can come here for your master thesis. I don't think this is an issue. The most important thing is that you should tell us what is your main field of expertise, what you're working on, what you would like to work on during the thesis, to see whether there is an alignment with the interests of the professors here. But I believe this is sorted out by email, and yeah. So this student, Alex, is wondering whether, okay, he's wondering about the basic level of statistical learning. So what is going to be required in terms of basic level in terms of statistical learning in the entering procedures, in the admission procedures? You guys have any? I'm wondering whether the professors have any answer.
Well, I can try to answer this question. I have idea that, yes, we ask for some basic knowledge arriving at our master degree, but the course in statistics is a basic course. And so I think that even a student with very few or basic knowledge can start studying things in the course, and it's I think that is not the basic idea of data science was to have this opportunity for the students to start from the very beginning in these courses. Clearly, if you know already something, it's easier, but if not, you have time to follow up and to study all the things that maybe missed in your previous studies. And so I think that, yes, it's possible to start even if you have very small or basic knowledge of statistics, like of probability and other topics.
Yeah, then there is Veronica. She's wondering whether she can skip the 12 CFU, the self-credits in CS basis in all the curricula if a student comes from a computer science degree. So I believe this is doable. What do you think, Marco?
Yes, it's. I think that it's always possible. In the curriculum in machine learning is already started to allow this without any problem with the constraints that we have to give a title at the end. And for the other curricula, it will be studied a little bit more carefully. But I think that in almost all the cases, it's possible to do this change from the basic course in computer science to change this with other courses. For sure, machine learning is optimized in this sense. We have studied the courses to make this easy, possible, and well structured. For the other curricula, it will be possible, maybe not so in a very so well like for this curricula, but I'm really convinced that it's possible.
Yes, then Veronica, she's also wondering whether where she can find elective courses among which she can choose from. I believe they will be available soon. We are going to publish them to the website soon after this presentation, right? Beginning next week.
Yes, of course.
Maybe if I can, Michele, add a few words here. Probably it was, I mean, I don't remember exactly, but I think that no one of us has said anything about the elective besides the ones that are the optional courses during the presentation, I mean, of the curricula. So in general, the electives for all the curricula are all the courses appearing in one of the curriculum. So if you look at the 4 different presentations, then obviously you'll find all the information also on the official page of the university. There you'll see the entire list. But in general, the electives are all the courses that have been that we are offering in any of the curriculum.
So then there is a student is a math, UniPD, University of Padua mathematical student in mathematics. He has a question whether he can submit the admission, apply, even though he hasn't got the degree yet, but he's going to get the degree within this year, 2020, for example, December 2020 or March 2021, the latest. So Laura, what do you think?
Yes, he could apply and then he can take his degree, but he has to submit his application now. He's international students, right?
He's a UniPD student from
UniPD student, sorry.
Yes.
Sorry. Yes, of course. He has to read carefully the avviso di ammissione. He is coming. Avviso di ammissione will be published maybe tomorrow, but or maybe next week at least, surely. But he can apply also if he is not graduated yet.
Yes, but I'm not sure, but I believe that he has to finish by the end of this year.
Yes,
he can have graduation in February 2021.
At least.
Okay, so it's this is mandatory.
Okay, then there are a number of questions about students who were not accepted this year. They would like to know whether they can try again next year. And some of them they know that their academic background is weak, but they would like to improve it. So they would like to know how to do that. If you may have some recommendation.
Maybe Lamberto?
Okay. Yeah, I think, in general, we are open to, to evaluate again all the applications. Obviously, this depends. I don't know how bad is this background following what this student was writing. So, I mean, this year the competition was particularly tough because we got a lot of applications and we have a limited number of seats. I don't know. It might be that next year maybe we might have more places. So I don't know. But I mean, if the student is really interested in applying again, I think we can probably early on during the year we can try to contact us, and so maybe we can also update him or her about if there are any changes. But in general, I think it's probably our evaluation will not, if nothing changing in the changes in between. So if the curriculum is almost the same, probably is not going to change a lot. But depends on the case. If it was a borderline case, it might be that next year you can get in.
So related to admission, there is Nora, and she would like to know whether there are any additional requirements, such as a minimal GPA for already conditionally admitted students.
I mean,
No,
if you want, I can also answer to this one.
Yes, yes.
I think she's one of our admitted students, so she's already
okay.
She's been admitted, so she's more than fine.
Yeah, and also a number of questions about the, of course, how the courses will be offered in September 2020. So we do not have a final answer right now. Nobody knows. The situation is improving fast here. Hopefully it will be almost back to normality by September, by fall 2020. We don't know yet for certain whether we're going live in the class with the student. I believe this is just my best guess. There will be a sort of mixed situation. So we will provide the online material anyway, so the student could participate, even though we go to attend the live lessons. I believe the professors will be requested to put the material and even the presentation online of their lessons, so the student can also attend, even in the case they are not able to come here, for example, for visa reasons or for any other issue with the travel. I believe though the students are, so my take would be, personally as a professor, would be to anyway prepare during the summer the video lessons and all the material that is required in order to be prepared to offer a fully online course, as I did this semester, in this present semester actually, and I believe many of my colleagues will do the same. Then there is a question about the quality of this teaching activity in an online fashion like that. I am certain that the quality is going to be very high. We were discussing this together with Marco, the president of this data science master, and we received very good scores from the student. We were evaluated very highly. All of us have been providing online video recorded lesson in our University of Padova. We are fully equipped with a number of software tools to record our lesson from home, and also we have an integrated system for the student where they can access the system and have all the materials like the videos, the slides, all the PDFs that are needed, and even the books from the library can be linked. So we from this integrated system, we can organize some live interactive lessons with the students as well, not only offline recorded. We can also organize some study classes, and many things can go on. And this worked out to very, very nicely this year. So I believe the quality, in some cases, it was a little bit more difficult for sure for all of us, for you as a student and for us as professors, but I believe the quality was not that impacted. Also, some students were very happy, and they said, I would like to get this same amount of material even when we go back live in the class. So this is, I don't think is going to be a big issue. Yeah. So yes, can we take some extra courses from other departments? For example, physics. I believe this is doable. It should be evaluated with the commission, on a case-by-case basis. But yeah. And is it possible to switch from one curricular program to another during the master at the end of the first year? Lamberto, you have something to say, I believe.
About this one or the previous, you mean?
Both of them, but
okay. No, yeah, just a quick 2 words about the previous question. So as Michele was saying, you can add new elective courses that are not in our standard of offer. But in particular, we have the 12 credits that usually corresponds to 2 courses that are actually completely, free. You can do basically whatever you want. So this to say that for sure you can, it is supposed to be obviously something related to what you are doing, but it's in theory, you can really pick whatever you want. So there are no real limits on it. And about the second one, the one regarding if you can switch the program, maybe Marco or Francesco can also add a few words about it. But yeah, I think it's definitely doable. In particular, as you have probably seen in the presentations, the first year, there are differences, but most of the mandatory courses are the same. So I think that it's definitely doable.
Possible.
Yeah.
If I may add, yes, I completely agree with Lamberto. If you want to switch from one curriculum to another, I think this is pretty doable at the end of the first year, so there should be no problem at all.
With that, I believe we have completed and answered all the questions that we received so far. Oh, there is one more. Okay, yes. So Alex is wondering how can he prepare himself for the curricula of biological data analytics, because he does not have any, or he does not have enough knowledge on biology yet.
I can answer maybe. I'm Damiano Piovesan. Yes, I think it won't be a problem because we expect people don't have a background on biology, and we can help also in the choice of elective courses. So you can pick up something to give you more extended background in biology. So, but for us, it's not a problem. We will cover basic biology in the molecular cell biology course. So it won't be a problem. And of course, if you want to expand on that, then we can select other courses and help you to select other courses.
Then I don't remember whether we already discussed this one from Farouk. Can students in medicine with good mathematical background and willing to learn coding and machine learning be admitted to biological data analytics? Why not? I don't think it's.
I think the problem is the criteria requires 30 ECTS. So maybe if someone can cover the credits, it can be accepted. And I think also we are planning in the future to relax those criteria. So probably maybe not this year, but next year it will become possible.
Yeah, but
for regular students.
Yeah, this is correct. I mean, we have some criteria which are on a number of credits in several topics that are technical topics in mathematics, statistics, some programming. They are not a lot, so they are not very strict and not very demanding, but we do need them, as my colleague said right now. So it's better if you are really interested. You could do two things. The first one is to take some extra courses just to become eligible. The second one is to write to us so with your curriculum, so we can have a pre-assessment and tell you whether it is okay or not. Okay. Then the last question is, when should we choose a curriculum program? Laura?
Okay, now you enroll to your first year and you have to do your all your mandatory exam. And I don't remember, at least at the end of the first year, you have to choose for the program, one of the 4 program. It's right. I asked to our president if it's correct.
Yes, it's something that we haven't decided exactly yet, but I think that we will have to ask earlier to choose between one curricula and the other, because there are some differences in the first year too. And so at the end of the first year, maybe it's too late. I think that at the very beginning, we will ask to the students which curricula do they choose, and so what they, yes, which curriculum they have chosen, and they can change at the end of the first year for sure, but it will help them, because us and them to have an idea of how many students will follow one of the 4 curricula.
I would say that's all. I don't see any other questions.
Maybe I think we forgot this to answer to this question from Giacomo, that he's asking what are the main differences between our machine learning curriculum.
You're right. Yes.
And the one from physics of data. Maybe I can say a few words, and if you want, you can, add other comments. So I'm not super familiar with the physics of data program, but we are actually doing some common initiatives, in particular regarding seminars and the impact of machine learning, AI on society. So that's the reason why I partially am aware of what they are doing. And so in a nutshell, I think we can say that the physics of data master program is a data science program focused on the computational physics. So is highly tuned on machine learning, but it's that's the context. So it's their expertise is on physics, on computational physics, and how to use the machine learning tools and techniques to address problems in physics. So there are for sure things that are in common, but in general, our data science program, and in particular the machine learning and intelligent systems program, is tailored around the main general tools and application of machine learning in almost any domain.
Okay. So I asked the student whether they have any other questions to write in the chat. If not, I would ask the professors if they want to conclude with something that we haven't mentioned. Or
I saw one question that somebody asked if this material, our presentation, will be available on our webpage. Of course, everything will be posted on the webpage very soon, and so the description of the 4 curricula and the whole presentation, you can find everything in the webpage.
Yeah.
And maybe I can show the T-shirt of our master degree that I'm very proud to wear. It's very expensive, but because it costs 2 years of your life, because it's a gift that we give to the students when they graduate, but it's worth because it's very, very nice T-shirt.
Yes. So one last question from Greta. She got a bachelor degree in mathematics achieved in Padova. In the study plan, she only got 6 credits in 01. So, but the minimum required would be 8 credits. So could she and join data science anyway? This is the question.
Lamberto, what do you think?
Yeah, I mean, I think that this is, in general, the cases that are, might be not let's say, a strange case, because it's from mathematics, so it's not from a weird class. But I mean, in general, I think that depending on the particular curriculum, we can, as we are actually doing with international students, we can evaluate on a personal basis. So I don't see great problems if maybe she has also some background on I don't know, on computational methods or stuff like that. That it's not really computer science, but it's related. So I really think that this depends on the. So my suggestions would be to keep in touch, and so let's see the. I mean, we can evaluate the. I will not say no in. I mean, it does. If it's just these tools, ECTS that are. No, I mean, the missing part. Does not seem to me a great problem, especially if her curriculum is somehow balanced in a slightly different way. So we can definitely evaluate also looking at what she has done. This is my opinion, but maybe Marco or also Francesco that are sharing with me the most of the selection, especially international students, can add.
If I say something, yes, I completely agree again with Lamberto, because in the end, if you take a look at the computational mathematics exam that we have here in Padua, there is plenty of coding and stuff like this. So maybe evaluating the curriculum would be of the student would be the best to choose if he can, overcome those 8 CPU that are required for the admission. So maybe we should analyze in depth the curriculum in the end.
Yes, I want to add this. I agree with my colleagues. I think that the rules are needed to be able to, these are automatic way to enter without any control. And if there is some missing a couple of first credit in some place, and so we can evaluate this. But this is my hope, but I'm not sure that it will be possible. And so maybe it's better we will, it's very clear. I don't know how to explain exactly. It means that maybe the secretary will stop the enrollment of a student because it not satisfy our requirement of credits. And so what we can say is try to have all the requests satisfied. If not, and if it will be possible for us to evaluate this curricula, we will for sure take into account if the reason why there are 2 credits missing, and so we will probably be able to admit, but it depends if it will comes to us this kind of evaluation. It is possible that it will be stopped this before. So this is the reason why these criteria have to be very well organized and thinking very well about which constraints that we put to enter to data science because of this event. And so maybe it's better to be sure to add what a couple of, I don't know, add a course of computer science with some credits in this topics to be sure to enter without any limitation. And if you have problems, please contact us and we will try to understand if it is possible to avoid this filter.
Yeah, probably I add just a few words because we were discussing with other colleagues, and it's probably, as Marco Ferrante was saying, it's probably better to contact us before doing your application. So this way, before going into the bureaucratic administrative process, maybe we can. It's better if we chat in person. That's just to add. I mean, in terms of procedure.
Yes, this should respond also to Amin. He is wondering whether, as an industrial engineer, he could be joining us. I believe this depends on the number of credits that he has in the different fields, like probability, mathematics, and programming. So you go to the website and check the criteria that we have, the requirement, the entry requirements. And also, as well, you can send us your CV, and we will tell you whether this is possible or not. Okay, so if you, Marco, agree, I would call it a day. I would close here.
Perfect.
And thank you, everybody. The students, especially.
Yes, thank you. Okay.
So we made it. Bye, everybody. So we wait for you.
Bye-bye.